Good morning and welcome to a session on number properties. And our learning intention today is how to reduce a composite number into its prime factors. So before we start the lesson, really important to understand the definitions. We did the definitions yesterday, but just a reminder. First things first, a prime number is a number that is only divisible by 1 and itself. For example, 2. A composite number is a positive integer, so a positive number that can be divided, created by multiplying two other positive numbers. So for example, 8. Yes, 8 could be created by dividing by 1 and 8, but it's also created by 4 and 2. Therefore, 8 is composite, 2 is prime, and these guys are opposite of each other. Factors we had a look at yesterday, and once again, a factor is a number that divides into another number exactly without leaving a remainder. For example, a factor of 8 is 4, because 8 divided by 4 equals 2 equal groups. All right. Today, I'm going to show you two methods to reduce a composite number into its prime factors, and I'd love you to practice with those. All right. The first method is going to be a factor tree. Factor tree. Sounds like factory, but it's not. A factor tree method. A factor tree method works by circling your prime factors when you see them. All right, so let's have a look at the prime factors and going from there. The first one, 2, is actually a trick question because this is already a prime. So we're going to circle that one, and that is done. Our factor tree for that one is done. Doesn't look like a tree, looks like a circle, but oh well. Next up, we're going to break down 8. And the way you break down a number is by reducing it to its prime factors each time. So think about a multiplication to get to 8, first of all. Not 1 or 8, because 1, technically speaking, is not a prime factor. So usually you'd start with 2. So let's go down 2. And how do we get to 8 by multiplying by 2? Well, we multiply it by 4. All right. So now I can see that 1 prime factor has been created. So I'm going to circle that. That's 1 prime factor. But 4 isn't broken down into its prime factors because I know I can divide that by 2 as well. So we're going to divide that by 2 as well. So we've got our 3 prime factors. So to create 8, I would say 2 times 2 times 2. And we know that we can actually use a cube here. We could say 2 to the power of 3 because that's 2 cubed. And that all equals 8. If you times 2 by 2 by 2, you will get to 8. Alrighty, up next, we've got this lovely 24. Let's move this one out of the way and go from there. 24 is a little bit bigger. So we're going to keep going with our factor trees and having a go at this one. Let's use the 2 method once again. So I know that 2 times 12 equals 24. And 2, of course, is a prime, but 12 is not there yet. So let's keep breaking 12 down into its primes. I can break that down into a 2 again. And this time I can times it by 6. Let's keep going with that one. So 2 is a prime. And now we're just thinking about our next step. So I'm going to break 6 down again into 2 and 3. 2 times 3 equals 6. And they are both prime numbers. So now we know for 24, it's going to be 2 times 2 times 2 times 3, which actually could be, is equals 2 to the power of 3 times by 3. And those will equal 24. Remember, when you're doing a power, you're breaking it down and saying, look, times 2 by itself 3 times. So 2 times 1, obviously another 2 and another 2. When it's 2 cubed, you're timesing it by itself 3 times. 1, 2, 3. There we go. And times by 3 to get us to 24. Now, sometimes these factor trees won't go for 3 straight away. So let's, for example, say that instead of doing 24, we'll actually do the number 27. Okay? So instead of having 24, we've now got 27. And unfortunately, when it comes to breaking down 2s, 27 won't be able to be broken down into 2 because 2 times 13.5 5 is 27. So that's not correct. You can't break it down into a decimal. We need an integer. So start by 2s. If it doesn't work, go to 3s. And I know that 3 times 9 is 27. So 3 is a prime number, tick. 9 is not, so we'll keep breaking that down, and that will be 3 and 3. And they're all primes. So to make 27, you know that that is 3 to the power of 3. 3 times 3 times 3 equals 27. Excellent. So those are factor trees, and breaking it down into prime factors is the key point. You may have to try different numbers to get down to the primes. Remember that 5, 7 is they're also prime numbers, so they will hopefully divide equally as well. Another method that I like to try is dividing by prime number step by step. It's similar to a factor tree, but this time you're just enjoying the idea of working quite methodically. So each time we're going to divide by prime numbers and see what happens. So the prime numbers below 10, we will do our 2, 3, 5, 7, and then 11. But really, we won't need 11 for this one. So first things first, we're going to use the number 147 and divide number by 2, because that's our first prime number. And I can see that it's not an even number, so it won't be, because that equals 73.5. So I know that 2, it means 2 is not a factor. Okay, we'll move on now and we'll divide it by the next prime number, which is 3. Divide number by 3, and that equals 49. And obviously I'm doing that quickly, but you guys will have to work out dividing it with a calculator. So the first factor is 3 because it goes into 147 49 times equally. So I can put that there. Means first factor is 3. Okay? And I'm going to write that factor just here. Next up, we're actually down to the number 49. So 49 is our new number. So we're actually going to divide that new number by the factors again. So if 2 doesn't go into 49. So I can say divide by number 2 equals, 24.5. So that isn't a prime number. So I'm going to try divide new number, which is 49, by 3. And dividing a new number by 3 will actually equal 16.33, which means it is not a factor. Or 3 is not a factor. Means 3 is not a factor. Now I'm going to divide the new number by the next prime. So let's divide the new number by, we've done 3, so now it's 5. So let's divide new number by 5. And that equals, does it split equally? No, if I was going to work that out, it would be 9.8. So it means 5 is not a factor. Now I'm going to divide the new number by our next prime, which is 7. Divide new number by 7. And I can see straight away that 7 will be another 7. It's actually equals 7. 7 times 7 equals 49. And that means that 7 is a factor. All right? So it means that our new number is 7. Now, you may think, oh my gosh, we have to go through that process again. Well, don't worry, because I know, let me put that just over here so we can do it. 3 times 7, and we're not sure yet because 3 times 7 at the moment is 21, so we're not at 147. I know that 7, our new number 7, is still a prime number. So technically speaking, we're done. 7 is our final situation. So 3 times 7 times 7 will get us to 147. So this method is called step-by-step factors. Okay, so what I'd love you to do is use step-by-step factors and also factor trees to decide on the prime factors for several composite numbers. Okay, you will do that using Google Docs on our maths classroom. So click the link, it'll take you to the maths assignment, and then I'd love you to submit your work. Use Explain Everything, but make sure you click Hand It In. Look forward to seeing all of your answers.